Hello, my name is Emily, and today I'll be going through my chosen digital technology by the Math Learning Centre called the Numberline app. So students can expand their opportunities to learn mathematics. The Numberline is a very simplistic virtual number line. Teachers can use this tool to create examples, to fill in numberline answers with students, and it allows students to create their own number lines. It's very effective using the teaching application of I do, we do, you do. Now with the Numberline, you can adjust the settings. This can be adjusted to your learning. If you're doing fractions, you can simply select fractions and which one will be the best for your needs. For example, quarters. It can be spaced accordingly for an easier visual for different students, as seen in the background. The Numberline is easy to manipulate for intervals of numbers, as seen in the settings, and creating equation tools. With equation tools, we have the ability to use money and financial mathematics using the dollar sign and the cent sign, such as $1 plus $1 will equal $2, as represented just here. In addition to the equation tool, there's the freedom of a drawing tool. The drawing tool, as seen here, will allow students to highlight numbers, seeing where they got their answers from. Maybe not appropriate to use fractions in this instance, but would need to go back to whole numbers. This will allow for students to make their own judgments on what settings will be best for their learning. Here lies the content descriptors from the Australian curriculum in mathematics. The two I've chosen to explore in further detail is Year 2 and Year 3 as pictured. In the Australian curriculum, the general capability of ICT can be incorporated into most descriptors because of the dynamic environment our students and teachers thrive within. Applying digital technology into mathematics expands on students' learning opportunities because the application caters for diverse learners of visual, auditory, when using speech-to-text for written parts, a virtual hands-on approach, and it allows the students to present their findings to peers as verbal learnings too. The app includes the option to share a code for another student to review and provides a network for communication between others. The extension to the app caters for collaboration between peers, where this can expand learning opportunities for students as group work can be added using this tool. Then to the content descriptor pictured, the easy use of manipulating the number line to start at any number. So we'll look at our whole numbers, 1s, 2s, 5s, 10s onwards. And you can apply jumps into the line, and this will help to instill confidence in a Year 2 to use this application from a virtual engagement. Students will be able to select different intervals to either increase or decrease, as seen here. So if we select 1s, and we'll keep our spacing wide just for the purpose here, and we'll keep it the same increase. We're increasing in 1s. And we can see the pattern continue. Now if we clear here, and we want to still count in 1s, we can actually go backwards. So this will give us indicators as green is increasing and red is decreasing. This is really clear indicators and especially useful for Year 2s to depict whether they are on the right track. The application provides students to make these type of discoveries on their own and fosters a student-driven learning environment to assist learners to become independent. The elaboration of the descriptor of recognizing patterns in numbers and sequences, such as adding 10 always results in the same final digit, can also be explored through the use of selecting whole numbers and counting in tens. The digital technology helps users learn the maths more effectively and in depth from the simple use of modifying which number students will choose to increase or decrease from. In a traditional written number line, students may feel that they are judged on their neatness, their ability to draw a straight line, and plot numbers equally on a line by a teacher, and that this is more important than the actual content that is being learned. This app eliminates the traditional approach where that was marked against how well a student was able to comprehend a topic, and this is not an accurate indicator of a student's understanding. Just going back to the content descriptors, we'll now look into the Year 3 model and represent unit fractions, including half, quarters, thirds, fifths, and their multiples to complete a whole. I'd like to look into the Year 3 content descriptor, just pictured. Okay, so we're just going to have a look at our fractions. Fractions, we'll select here, and we'll go into quarters. Year 3s will investigate the relationships of halves, quarters, thirds, and fifths, but just this example, we'll select 1. I've chosen also the larger spacing to give a better visual, as it may be more difficult for students to navigate through a more narrow space setting for their first time. Going here, I'd like to first start with our text. What is 3/4 of 1? We'll have a look. 1, 2, 3. Using the 3, we'll just circle the 3. Notice how there's not 4/4. This is 1. This is represented as a whole, which helps with the content descriptor. With the free tool drawing, we can now draw just what our fraction would look like. This also allows students to be more creative with their work and encourages engagement. And they know that a quarter will be divided into 4. So if we follow the lines, we'll notice we have approximately 4 equal parts. So looking here, if we want to go 3/4, we can demonstrate this by shading in up to 3/4. I just continue to shade very quickly of 3/4. You can see 3 boxes are shaded and 1 is not. We can also word this of I have eaten 3/4 of 1 chocolate bar. Moving into a learning opportunity for Year 3s, the ability to create a model of what 3/4 look like and represent this on a number line helps instill a visual image. This is extremely useful as it allows students to make discoveries from their original thoughts of which fractions are actually bigger. Where some students may actually think the fraction with the larger denominator is the largest, when in some cases it is not. The text box can be used by teachers to provide instructions to students, such as indicated in the image as well, and students can also use this to represent what they have just drawn. This is used to consolidate the students' learning. I believe that using digital technology in mathematics can be a very useful and efficient tool when used appropriately by students. To effectively use any digital technology, students must have an understanding of how to use the tool first, of which time will need to be allocated for students to grasp the basics of using any application. Using digital technology as a tool allows students to travel at their own pace of learning, where there is a differentiation of learning abilities, such as the removal and inclusion of numbers on the line, creating models of the fractions, using jumps to create a sequence, etc. In the tool I've selected, for example. The tool I've selected is a proficient example of how using digital technologies align with aspects of the ACM. However, it is not always appropriate to use this tool for all mathematics learning. This is such as identifying angles in measurement and geometry. This will require the use of a protractor, and this app does not include that relevant feature. And lastly, thank you for listening to my presentation for Assessment 3 using digital technology. Thank you.